All right, this is Ken Rosever, and we are going to be talking about estimating the mean of group data. What we have here is a histogram that's been classified or grouped. All the data has been put into classes. It's been grouped, and now we don't have the original um, values to work with. Instead, we have this histogram. So if I ask you to find a mean, normally I would give you a list of numbers and you'd add up all the numbers and divide by the number of numbers. In this case, we have 50 students who took a math test and their results were as followed, but they're arranged in a histogram. So I don't know anything more about these 6 students here who scored between a 550 and a 600, other than that they scored between a 550 and a 600. I don't know if one of them got a 575, another got an 80, a 551, 5, I don't know what they got. And because of that, because I don't have the actual list, I can't actually determine what the actual mean of the sample is. What I can do is I can estimate it based on this. And my estimate is going to be based on, since I don't know exactly where these 6 kids are in here, these 6 students, I'm going to base it on the midpoint. Now, normally, you add up all the data and divide by the number. In this case, I'm going to go through a process that pretty much amounts to the same thing. Since I don't know what these 6 students got, I'm going to say they all got 575s. Since I don't know what these 11 students got, I'm going to say they all got 625s, which is the midpoint here. These 13 students, I'm going to say they all got 675s. These 11 students, I'm going to say they all got 725s. And these 9 students, they all got 775s. And I'm going to add up all of those and divide by 50. And that is going to be my estimate of the mean. In case you didn't follow that, I'm going to do it a little more slowly now. What I did is I've copied this information along with some information from your book, which is found on page 116. It is a procedure for estimating, finding the mean for group data, and it tells you what to do. The first step is to make a table with class, frequency, midpoint, and frequency times midpoint. To fill in the table, we're going to find the midpoints of each class and place them in the columns. We're going to multiply the frequency of by the midpoints for each class and place that product in column D. We're going to find the sum of column D. That sum divided by n will give us our sample mean, or our estimate of the sample mean. Okay, so let's go here and do it. First thing I'm going to do is I'm going to have my classes, my frequencies, my midpoints, and my f times xm. I'm just going to, instead of calling my classes 550 to 600 like this, because that's a lot of work, I'm just going to call them class 1, 2, 3, 4, and 5. Okay? But as I do that, I'll keep in mind that class 1 is 550 to 600. So I have 5 classes. The frequency of the first class is 6, then 11, then 13, then 11, and 9. The midpoint of the first class is 575. Of the second class is 625. Of the third class is 675. And once I do the first class, by the way, because it's 575, and I know these are skipping by 50, the midpoints, 575 is the midpoint, right? It must also skip by 50 to arrive at the next midpoint. So, which would be 625. And so I don't actually have to do the calculation of midpoint, which is the low boundary plus the high boundary divided by 2. I don't have to do that. I can just figure it out in my head. Okay, so we have 575, 625, 675, 725, um, and then 775. Next thing we're going to do is we're going to go f times xm. And to keep this straight in your head, how do we know to do that? Because remember what I said when I was explaining this, that in here, we don't know what these 6 students actually scored. So I'm just going to say that all 6 of them scored 575s. So it's like I have a list and there's 6 575s in that list. There's 11 625s in here. Now, rather than put a list with 6 575s, 11 625s, 13 675s, 11 725s, and 9 775s, which isn't even easy to say, I'm just going to multiply. Because if I have 575 plus 575 plus 575 6 times, then don't I have 6 times 575? Well, that's this column here. Okay, so 6 times 575 is 36, 34, 50. And that is, let's see, 6, 8, 7, 5, 13 times 675. I don't know. I'm going to pause and use the calculator. Hold on. Okay, now that I have those all totaled up, or yeah, totaled up or multiplied out, now I need the total because the total it represents the total score of all these students. It's my best estimate of the total score. I don't actually know what the total score is, but I do have a decent estimate now based on this information. So I'm going to add up all this. So now I have 3450 plus 6875 plus 8775 plus 7975 plus 6975, and I hit enter, and that total is 34,050, which I'm going to divide by 50, and that'll give me my average. So divided by 50, something with a 1, 681. So my answer is 681. And that's how you do it. Okay. You don't actually have to use this column method if you just remember what I said at the beginning. You do the midpoints times the frequency divided by, all added together, the sum of the midpoints times the frequency divided by n. If you can remember that formula, you'll be pretty good. Let me go back to Alex, and I'll show you how to do it using the Alex calculator. In the Alex calculator, we can quite simply use a large parenthetical statement for the numerator, which is the sum of all the frequencies times the midpoint. So 6 times 575 plus 11 times 675, oh no, 625 plus 13 times 675 plus 11 times 725 plus 9 times 775. Close that parenthesis and then hit divided by your sample size, which was 50, and you get 681, the same answer we got. And we're going to type that down here. And hopefully it'll say we did it right. Woohoo, very good. You seem to have mastered this question. Okay. Um, that's it. That's how you do it. Okay. Have a nice night or day. Bye.